This will be the first of two videos where you're given the coordinates of 2 points of a line, and you'll be asked to write the equation of the line as well as to graph the line.
So this is part one of this overall lesson in order to keep the video somewhat reasonable as far as length goes. So for the first one, you're given that the line passes through 4, -7, and 9, 0. So the first thing you're going to need to do is figure out what the slope of this line is going to be to write the equation of it. The graph can be done just by drawing the picture. I mean, that's no big deal. I mean, there's the 2 points, and technically all you have to do is draw the line through them. But the first thing that is, if you want to write the equation of it, notice we can't even see the y-intercept here, so I'm going to need to find a way of determining what that is here. So, but so first let's figure out what the slope of this line is. Well, the slope is calculated by me subtracting the two y coordinates in the numerator of a fraction and subtracting the two x coordinates in the denominator. It doesn't matter what order you do the subtraction so long as the order is preserved when I go from one ordered pair to the next. So since the -7 here was the first um, y coordinate I used, I should use its corresponding x coordinate first on the bottom. And so when I work this out completely, I get -7 over -5, which is 7/5. Yeah, you could also write this as 1.4 if you so desire. But typically, in order for us to get an idea of what the slope is telling us and how it's moving, um, having it written in this format, it lets me know there's a rise of 7 and a run of 5. So, I mean, I can even see here, if I go from point to point, if I go up 7, 1, 2, 3, 4, 5, 6, 7, and I go right 5, that takes me to another point on the line. So, um, with that, I need to find the y-intercept. There's a couple ways that I'm going to be showing through these videos how to do that. But the first way is I'm going to first, start by writing this in point slope form. In point slope form, if I pick this first point here, 4, -7, as my quote-unquote starting point, then I would do y minus -7 equals 7/5, the slope, times x minus 4. Where, of course, this would be my x1, this would be my y1. And what I would do at this point, well, y minus -7 is a y plus 7, and that's the way you would probably see it written most commonly, because subtracting a negative makes it a positive. In order to put this into slope-intercept form, all I really have to do is solve for y. So I'm going to multiply this right-hand side through. I'm going to distribute that 7/5. I'm then going to subtract 7 from both sides. Well, I'm going to turn 7 to 35/5 and then carry through the subtraction. And I would get the equation y equals 7/5 x minus 63 over 5. Which is roughly about 12.6, so a minus 12.6. I can kind of see it's heading in that direction, but even the way this graph is scaled, I would have a little bit of difficulty interpreting the y-intercept as that. So of course at this point, if you wanted to, you could also then put this into a format of 1.4x minus 12.6 if you so desire. Wouldn't make it easier to graph or anything, but it could, if depending on what it's representing, decimals are fine. I'm just showing you in this other part here. If I had chosen to use the 9, 0 point, I would have gotten to the exact same conclusion as I did for the slope-intercept form with this too. So it doesn't matter which point you use in your point-slope form. When you convert the slope-intercept, you should get the same result. On to the next one. So you were asked if there was anything special about this line, and you have to make sure that you are paying attention to this, because this could save you some degree of work if you notice some things about it. It passes through -6,4 and 7,4, and if I were to actually graph those 2 points, plot those 2 points and graph the line that passes through them, I can see it's a horizontal line. Now, if you remember the facts that we learned in the previous lessons, if I have a horizontal line, that means that, the y is going to be at a constant value. The x can be anything, it doesn't matter, and therefore it won't appear in the equation of that line. So basically, a horizontal line that passes through these 2 points, which both have the same y coordinate of 4, would just be y equals 4. But sometimes students don't catch that. Maybe they didn't graph this, because ultimately you're supposed to be trying to find these equations without having to draw the graph of it. Or even if they didn't draw the graph and they don't notice that the 2 points have the same y coordinate, which sometimes is a big red flag itself, that is what you're going to do with it. You can still notice it and handle it if you perform the same steps we did in some of the other examples. So for instance, I'm going to find the slope, and I get 0 over negative 13, which means I get a slope of 0. So if I go to point slope form, and I'm going to be picking here the first coordinate, I'm using the negative 6, 4, I'm going to have y minus 4 equaling 0 times x minus negative 6. Doesn't even matter what goes on in here, because I'm multiplying it by 0 ultimately, so I end up with y minus 4 equals 0. And if I add 4 to both sides, I do get that y equals 4 again. So I can still get to the same equation of the line through the methods that we're talking about now. But if you notice some things about it, like the 2 points are giving you share a y coordinate, that would save you some work if you recognize it's a horizontal line and remember what the format of a horizontal line's equation should look like. Now let's try this one. So again, these are still 2 sets of coordinates. The nice thing about this one is that they do give you the y-intercept. So once I get the slope, I have the y-intercept. I could go right to slope-intercept form. And most of the time, your textbook and the work that you have to do in MyLabs Plus is usually going to request the slope-intercept format. But again, as far as graphing the line, since I do have 2 coordinates, all you gotta do is plot them and draw the line. That's what it would look like. Sometimes having the graph in front of you can help you figure out whether or not your answers are correct, because if maybe you find another point along the way, you want to make sure it's on that line. It's the kind of having the graph there can help you know if you're on the right track or not. So I'm going to calculate the slope. Again, I'm subtracting the 2 y coordinates on top, the 2 x coordinates on the bottom, making sure that the order is preserved. So I get y equals negative 5. So the negative 5 over negative 3 is the slope, which is just 5/3. And as I mentioned before, we do have a y-intercept here, so I know that b is 5. So I get right to the slope-intercept form of the equation, which is written in y equals mx plus b, and just say y equals 5/3 x plus 5. And for the last example for part 1 here, I want you to try this one. Okay, so again, the graph itself, doesn't help you figure out what the equation of the line is. But I mean, with 2 points given, it's not too difficult to draw. If I had other points along it, it'd be even easier. I don't have to use a straight edge, or in my case here, the computer to draw it nicely. I could probably draw it more by hand. But for me to come up with the equation of the line, though, I definitely need the slope. And if I have a point that passes through, which I already have, that's great. If I can find the y-intercept, that's what helps me put it in the slope-intercept form. But as I said, there's ways of handling that. So for this first one, I'm going to subtract negative 5 minus 5 over negative 2 minus 2, which gives me negative 10 over negative 4, which simplifies down to 5/2. So a point slope form of the equation of the line, if I'm using 2, 5 as my quote-unquote starting point, is I would have y minus 5 equaling 5/2 times the quantity x minus 2. If I want to convert that to slope-intercept form, I would distribute the 5/2 and get y minus 5 equals 5/2 x minus 5. And then I would add 5 to both sides and get that y equals 5/2 x. Notice that there's no plus b following it, which means that essentially the y-intercept is 0. or b is 0, which means that the y-intercept should happen at 0, 0. And you can see the line does pass through that. So that's kind of what I mean by sometimes if you see certain behaviors with the graph, you could use the graph to check your work because they should agree with each other.
And that is the end of part 1 of being able to write the equation of a line given the coordinates of 2 of its points. Please proceed on to the second video where you'll be asked to do some additional examples of this same topic.